Okay, the first three examples involve adding algebraic fractions with unequal denominators. And what I want to bring to your attention is this, and it's something that's very important that we recognize. This is x, and this x is the exact same x. All right? But this x is being added to a y, which makes this overall factor different than x. All right? So even though this x and that x is the exact same x, since this x and y are being added together, they get treated as one object that's different than the x over on the other one. If we're doing least common denominator, we're looking for different factors to find the least common denominator. When I look at the denominators of these fractions, x is a prime number. It's prime because there's no way I can do a factoring tree to break it down into two numbers that make x, because I have no idea what x is. So letters in general are prime. So the least common denominator is going to be created by those two things. X is one factor, x plus y is the other factor, and we're supposed to take the highest power that occurs for either factor. So looking at x, this x is to the first power, this quantity x plus y is being raised to the first power also. Even if this said x squared plus y, then this would be x squared plus y. It's still the first power, this is still the first power. That square there doesn't have any effect on this right here when we're trying to find the least common denominator. Keep that in mind. Okay, again, the problem as stated is right there. My least common denominator is x times x plus y, both of the first power. My next task then is to create a common denominator. I'm going to make one big long fraction bar. I'm going to place my least common denominator below that. And then I'm going to look at each fraction individually and see what changes are necessary to make the denominator I need. So how many fractions are there in the problem? Two. Which means I'm going to create two terms on top based on what the common denominator is and what the denominators were originally. So looking at the first fraction I circled in red, the current numerator is a. So I'm going to write a down. And the current denominator is x, but we changed it to x times x plus y. What's new?
X plus y.
X plus y. So since x plus y is new on the bottom, I got to put x plus y on top also. Anything I did to change the bottom of the fraction, x changed to this, I got to change the top the same way, and it's a multiplication process to make that happen. Looking at the second fraction, I'm going to circle in purple. The current numerator is plus b. The current denominator is x plus y. What's new?
X.
X is new. So x is new on the bottom, so I need to put an x new on top. I made this bar work too long, didn't I? So I fixed both numerators appropriately, right? The common denominator, I just made it what I want it to be. For each numerator, I had to ask myself, how did this change? Change the top the same way. How did this change? Change the top the same way. What's left to do now is to simplify as much as possible. Distributive property, where necessary. This is one thing times one thing, no distributive property necessary there. So that first one I'm going to get ax plus ay. The second one I'm going to get plus bx. All that goes over x times x plus y. I want the top simplified completely. The bottom can stay in factored form.
You want to distribute the bottom?
Well, you can if you want to, but you don't have to. I want the top completely simplified. The bottom can stay just like that, just in the multiplied form.
If you would distribute it, would it be x squared plus xy?
Exactly. It would be, if you did distribute, it would be x squared plus xy. That would also be legal, just as long as that stuff's on top over that. The top does have to be completely simplified. Make sure you do that.